Hi, today we are gonna presenting our research for the past 6 months. Let me introduce myself first. My name is Justinus Kosasi, and
And my name is Steven.
yep. Okay, so we picked up a topic, mobile development, native versus cross-platform development, which I break down into 3 points. The first one is, of course, the mobile development. The second one is native development, and the third one is cross-platform development. We did a research where mobile development has evolved significantly, moving beyond the early days of platform-specific language like Java for Androids and Objective-C for iOS. With the advent of Kotlin and Swift, native development has reached new levels of efficiency and performance. According to industry statistics, mobile applications remain pivotal, with the global smartphone market surpassing 1.43 billion units in 2021, and mobile devices becoming the primary means of internet access worldwide. Given the commercial and strategic significance of mobile development, understanding the technical considerations and limitations from a developer's perspective has become essential. Despite the clear benefits that both native and cross-platform approach offer, there remains a lack consensus on which approach is best suited for different project requirements from a development standpoint. Native development is known for its optimized performance and access to platform-specific features, but it can be costly and time-intensive, especially for teams that need to maintain separate code base for Android and iOS. Conversely, cross-platform frameworks promise faster time to market and lower development costs, but it often comes with limitations in performance and platform integrations. This study aims to investigate these trade-offs by analyzing technical aspects such as development efficiency, code maintainability, debugging ease, and lastly, integration capabilities for both approach. By focusing on these factors, the study seeks to provide insights that will help developers and development team make informed decisions about which approach to adopt based on project constraints and performance requirements.
Today I will present detailed analysis for native development and cross-platform development in mobile application. We will explore the different advantage and drawback followed by experimental result and their implementation. By the end of this presentation, we will have a clear understanding of when to choose one approach over the other. First, we have native development. Native development refers to building apps specific for a platform, such as iOS using Swift and Android using Kotlin or Java. The main benefit includes superior performance and seamless integration with device hardware and software. Study like a comparative analysis mobile application development approach, highlight native app speed, especially in data rendering and remote access. Native development is often preferred to large-scale projects requiring complex design and high-quality user interface. Next, we have Kotlin in native Android development. Kotlin, a prominent language for Android, officially supported by Google since 2090 brings several advantages. Google officially supports uh, interoperability with Java performance in simple text compared to C++ using just-in-time compilation. Modern features like no safety and simple syntax that change developer productive. This feature, combined with Kotlin efficiency resource management, make it a strong choice for a native Android development. Next, cross-platform development. Cross-platform development allows developers to create app to for multiple platforms using a single code base with framework like Flutter or React Native. This offers save time and cost, make it the ideal for startup or smallest project. However, trade-off includes slightly reduced performance and resource efficiency, particularly to tasks involving complex animation or real-time data processing. And next, we have native versus cross-platform development. In comparing these two approaches, native development excels in performance, user experience, and handling complex tasks, but requires code-based increasing time and cost. Cross-platform development offer efficiency in development time and cost, but many struggle with high performance requirement. Choosing the right approach depends on project need, such as size, budget, and performance expectation.
Okay. The methodology that we use contains 4 steps, which is data collection or data gathering, data preprocessing, comparative analysis, and experimental testing. So for the data collection, we focus on gathering comprehensive and relevant information on native and cross-platform mobile development to enable a robust analysis from a developer's perspective. A systematic literature review was conducted across reputable database, including Google Scholar, ResearchGate, ScienceDirect, and Scopus. The second step is data preprocessing, which involves gathering all relevant data associated with our topic, focusing on studies, articles, reports, and metrics that discuss both native and cross-platform development. By doing this, we aim to cover a wide range of developer-focused considerations, such as performance, maintainability, ease of use, and community support. Once we collect this source, we conduct a data scrubbing process to ensure only the most relevant, high quality, and up-to-date data are retained. This involves identifying and removing studies that may be outdated, irrelevant, or whose methodologies do not align with our focus. Once the literature review data has been gathered, we proceed with a detailed, comprehensive analysis between native and cross-platform frameworks, focusing on key aspects essential to developers, such as performance metrics, development time and efficiency, code maintainability, debugging ease, and integration capabilities. Lastly, in experimental testing phase, we perform experimental testing to directly compare the performance of React Native, which is a cross-platform framework, and Kotlin, a native development language for Android. The key main focus is on several key areas, including startup time, FPS, CPU usage, RAM usage, battery consumption, and of course, the app size.
When comparing native and cross-platform approach, here are the key metrics collected during testing. And performance insight, startup time. Kotlin apps are faster Performance insight, startup time. Kotlin apps are faster, ideal for time-sensitive apps, and frame rate, FPS, native apps maintains 60 FPS better for a graphic-heavy text. Resource usage, Kotlin apps use less CPU and RAM, crucial for older device. Consume less battery over time. Battery consumption. Kotlin apps consume less battery over time. App size, Kotlin produce small apps better for use with limit and costs. React Native reduce time and cost by using one code base, but trade-off performance. Kotlin require more time, but over time. Kotlin require more time, but over optimize debug and maintenance. Native tools like Android Studio and Xcode simple debugging while React Native relies on third-party tool which can be challenging for less experienced developer. Choosing the right approach, native development best performance critical apps like games enterprise solutions, and cross-platform development ideal for MVP, smaller project, or budget conclusion teams.
Okay, so for the conclusion, this study compares native and cross-platform mobile development, showing that each has strengths to specific needs. Native developments excels in performance, resource efficiency, and responsiveness, making it ideal for high-performance apps like games or enterprise solutions. On the other hand, cross-platform frameworks prioritize cost efficiency and development speed with a single code base, which is perfect for startups or simpler projects. However, they trade off slightly in performance and debugging ease. The choice depends on project priorities, performance versus speed and cost. Future research could explore broader testing and hybrid solutions to refine these insights. And with that, let me close our research presentation for today. Thank you for listening to this presentation. Goodbye.